Alrighty, folks. We're just going to start real quick here with a review of some conditions of congruence for two different triangles that you may remember from doing in previous years. And this is just like the minimum requirements for two triangles to be equal. You have to have certain bits of information, stuff like angle, side, angle. In other words, a side contained between two angles. If you know those three things and they're the same for two triangles, then both triangles are automatically congruent. And a very similar condition of that would be the angle, angle, side one, where we know the angle, the neighboring angle, and then the side. And the reason why that one works is because once you know two angles, you automatically know the third or whatever. So anyways, those are variations of some that you've seen in the past. You've also seen some other ones like this, which is, as you know, say it before I write it, side angle side, meaning you know the angle contained between two sides, and if those are all equal for two triangles, and the triangles are again equivalent. And the last one you probably know, think you know it, and it's side, side, side. If you know all three sides are the same, then that means all three are the two triangles are the same. Okay, so those are your conditions for congruence that you're familiar with, but there's one other one you may not be familiar with, and I know you're going to think that I'm joking, but I'm actually being serious. And that's right, the one that is the angle side side situation, where you have an angle and then the next two sides. So you only know one angle and then the two sides, but not the angle between the two sides, just next to them. Okay, and the angle side side as condition of congruence has some difficulties that we have to um, take into account, and it's something called the ambiguous case. And this results from just properties of a triangle. So I'm going to set one of these questions up and I'll show you what I'm talking about here. Okay, so if they don't give you a diagram, they just give you this information like what the angles are, what the side lengths are, you have to draw the triangle yourself. And so if we do that, looking at angle A to start with, okay, we see that angle A is 35 degrees. And then it says that side A is 6. That's going to be over here. I'm just going to draw it like that for now. Okay, and then it says side B is 8. Well, let's just say the vertex B is over here, which would make this 8. Okay, and now the question is, what does this triangle actually look like? Just want to pause here for a second and switch to a different program and show you what we're looking at here. Okay, so this is the example that I'm talking about then. I have that angle there that's 35 degrees, and the opposite side is 6. I haven't joined it up yet. And then the other side there from B is going to be 8. Let me just put some more labels on here for you. Okay, so we don't know how long AB is. All we know is that AC is 8 and CB is 6. But look at what happens here if I swing that leg over here, this last guy here there, okay? I could join this up kind of right here. Let me just kind of make this a little bit longer here, okay? And this triangle could be formed like this, or it could be formed like that, giving two very different triangles. Okay, and this is the ambiguous case that I was talking about. There's two possibilities for your angles. Okay, and this only happens in some situations, but it is possible to get two different triangles. Okay, or if this line here is not long enough, or let's say, for example, this angle is too big, okay, it's possible to not have any triangles possible at all. Like if this was like that, it doesn't quite come down and touch there. I'll make it a little bit bigger there. So if the angle is too big, okay, then it doesn't actually make a triangle. All right, so if we're 51 degrees and 8 and 6 side lengths, you can't make a triangle like that. And for some of them, you can only make one triangle if you have this side here be too long. Okay, like this example here, where this kind of lines up with that point there, but if you swing it too far to the left that way, it goes beyond A, and in fact it doesn't make a real triangle because it's too long, right? In which case there's only one triangle possible. Okay, so you'll often get situations where there's 0 or 1 or 2 triangles possible depending on the angle and the side lengths. Let's look at some more examples in the next video.